Welcome to this section of the course titled DevOps Fundamentals. In this section, we will discussing about what is DevOps, what are the important cultural aspects of DevOps, and what are the important practices related to DevOps. After that, we will discuss the evolution to DevOps. We will start with how we build software in waterfall model. After that, we will talk about agile, and after that, we will talk about how we evolved to DevOps. And thereafter, we will dig deeper into the practices of DevOps. The important practices of DevOps are continuous integration, continuous deployment, continuous delivery, infrastructure as code, standardization. This standardization is made possible by Docker and Kubernetes. And the other important practice of DevOps is observability. We will be discussing each of these with a lot of examples, and we'll be looking at several tools which will help you to implement these as well. So we'll be understanding continuous integration, continuous deployment, continuous delivery, infrastructure as code, Docker, Kubernetes, and also observability. After that, we will be talking about, can DevOps be done without cloud? This will be a very interesting section where we'll get introduced to the most important concepts in DevOps. Are you excited to learn more about DevOps? I will see you in the next step. Welcome back. This is Rangakarnam, and I'm really excited to help you learn DevOps and review some of the important things related to cloud. Let's get started with talking about what is DevOps in this specific step. Whenever we talk about a software project, you have a number of teams. You have developers, you have business analysts, you have operations team, and each of these teams have their own goals. Developers want to build features. They want to see the new features live in production. What does operations team want? Operations team want production to be stable. They don't want any production problems. They want very few changes in production. Earlier, developers and operations teams worked in silos, worked on their own, and this resulted in delays. This resulted in finger pointing and having no team spirit. Instead of doing this, can we build and run software together? That's what DevOps tries to do. It brings in a culture and also a set of practices. Very important. There are two important parts to DevOps: culture and also a set of practices. The goal is to bring development and operations teams together. The goal is to have a common goal for the entire software development team. The goal is to deliver software faster, safer, and continuously. Now let's dig deeper into the culture and the set of practices of DevOps. Before that, it's very important to understand that there is no strict definition for DevOps. If you look at AWS definition for DevOps, it says it is a combination of cultural philosophies, practices, and tools that increase organizational ability to deliver applications and services at high velocity. As you can see, this is a very generic definition. Good thing is that it's a short definition. However, if you look at the DevOps handbook, this is one of my favorite books on DevOps. This was one of the first books I read on DevOps before adopting DevOps. So it's a great book, but if you look at it, the definition of DevOps runs into a few lines. This is a very complex definition. So let's not really worry about what is the definition of DevOps. Let me talk about what are the important elements, what are the important focus areas of DevOps. Number one is collaboration. You want development team and the operations teams to work together across the software lifecycle. Number two is to have shared goals. You want to be able to build fast, release often, and stay stable. This is the goal of the entire team. There are no individual goals for each teams. For all the teams, whether we are talking about development team, operations team, or the business team, the goal is to be able to build fast. The goal is to be able to release often and stay stable while we are making a lot of changes. And DevOps is about the cultural shift. It's about breaking down the walls between different teams and bringing them all together. So that's the first thing. It's about collaboration. The second important thing DevOps focuses on is quick feedback. Business team might want a new feature, and if it takes months before it goes live, then getting user feedback on that specific feature takes a lot of time. We are in the world of continuous innovation, and in this kind of a world, you cannot release new features every few months. You want a much faster cycle. Defects and issues shouldn't wait. Developers want to be notified about code quality issues or unit test failures immediately. If I'm committing something into version control, and if there's a problem with it, if let's say the code quality standards are not met, or if there's a unit test failure, or if there is an integration test failure, I would want to be able to find that out immediately. I want to be notified immediately. I want to get quick feedback. Quick feedback enables continuous improvement. By having quick feedback loops, you can refine features and fix things faster. The last important cultural element of DevOps is automation. Whenever we talk about real-world applications, we have multiple environments, and you have multiple servers in each of the environments. And if you do things manually, if you're creating environments manually, if you're configuring them manually, if you're deploying applications manually, that is slow and error prone. Repeated steps by hand increases chances of mistakes. And it's not scalable. What works for creating one server will not work when we go for 100 or 1000 or 10,000 servers. And that's why automation is very important. You want to do things quickly and reliably. You want to be sure that when an environment is created is very similar to the previous environment or a similar environment. And that is only possible through automation. So what we are talking about right now are the cultural aspects of DevOps. In DevOps, you need a culture of collaboration. You need a culture where quick feedback is appreciated. And you want a culture where everything is automated. So that's one, the cultural shift. The next part of DevOps is the practices. What are the key DevOps practices? Number one is version control. You would want to have all code tracked in Git. This is something almost every project does, right? So you have a version control system, most probably it's based on Git, and you'd be able to have your code, your application code in Git. Next is continuous integration. Whenever I commit some piece of code into version control, I would want the compilation, I would want the package building, I would want the code quality checks, I would want the unit tests, and any other tests that we would want to run. We would want to do that continuously as soon as a piece of code is committed. That's what continuous integration focuses on. What is the advantage of doing this? Immediate feedback. If there is a compilation error, or if there is a problem with building the package, or if there is a code quality problem, or if there is a unit test issue, I will know it as soon as I commit the code. I am not the only person who's making use of the version control system. I might have other team members who are making use of the version control system. Once I commit the code, I would want to ensure that the code is stable. I would want to ensure that other team members will be able to pick that piece of code and work with it and be sure that there are no problems with it. And that's why it's very important to compile code, build the package, run code quality checks, run unit tests and any other tests as soon as code is committed. And this is what is called continuous integration. Now, what is CD? Continuous delivery or deployment? Continuous delivery or deployment takes continuous integration to the next step. You'd also want to automatically deploy to environments. You might have dev environment, you would have a QA environment, you would have a stage environment and a production environment. So you'd want to automate deployment to these environments as well. There is a slight difference in continuous delivery and continuous deployment, which we'll focus on in a later step where we'll discuss that in depth. For now, important thing to remember is that continuous integration focuses on doing everything automatically as soon as code is committed up to deployment to environments. When you also include deployment to environments, then it's either called a continuous delivery or a continuous deployment. The next important practice with respect to DevOps is infrastructure as code. Typically, we write code to build our application. How about writing code to provision environments, to create resources in our environments? Whenever I would want to create something in an environment, for example, I'm making use of cloud, I might need to create a private network or a VPC or a virtual private cloud. I would want to create a server, maybe a compute server. I want to create a database. So there are a lot of resources that you would create, and you want to create hundreds of such resources. And we would want to repeat this across multiple environments. How about automating this? How about writing code to provision environments, to configure environments? That's where infrastructure as code comes in. It's about using code to create your resources. Earlier, when we were talking about version control, we saw that all code should be tracked in Git. And over here, you'd see that infra code and application code. Typically, all teams have application code in Git. The goal with infrastructure as code is to have even infrastructure code. The code which is used to create infrastructure, it also should be in version control. So infrastructure as code, the goal is to automate the creation of your resources, your environments using code, and have that code in version control. The next key DevOps practice is something called standardization. Typically, you would be using a number of different languages to build your applications. Maybe Java, maybe Python, maybe JavaScript. You might be using different kinds of languages, and you might be deploying your applications on different platforms as well. You'd want to run your application on your local. You want to be able to run your application in a dev environment which is on premises, or you might want to run it on the cloud. If you have standardization in place, you can use the same processes irrespective of whether it's a Java application, whether it's a Python application, or if you're deploying on the local machine or deploying to the cloud. That's what containers and container orchestration enable. That's what Docker and Kubernetes enable. If you are making use of Docker and you are creating Docker images for your applications, then irrespective of whether the application is a Java application or a Python application or a Node.js application, once you create a Docker image, the way you would deploy it would remain the same. That would make the job of your operations team very, very easy. So the next element of DevOps, the next key practice of DevOps is standardization. You would want to make use of language neutral and platform neutral tools that makes things easy, that makes your processes streamlined. And couple of important things in that respect are Docker and Kubernetes. The last key DevOps practice that we'll be talking about is observability. Typically, you'll be running hundreds of applications in thousands of servers, and you'd want to find out what's happening inside the system. And that's why you'd need metrics. For example, what is the CPU usage in a specific server? How much percentage of the CPU is being used? How much percentage of memory is being used? Those are metrics. Next is logs. Typically, whenever you're building an application, applications will be writing logs. Even the servers might be sending information as logs. And you'll also have traces. Whenever there's a request, it might go through multiple microservices. You'd want to be able to trace the request across multiple microservices. That's where traces become really important. As a combination of these three, metrics, logs, and traces, these help you get insights into what happens inside a system. Metrics, logs, and traces are called the three pillars of observability. So getting information about what's happening in the system and using that to generate intelligence is what observability focuses on. So what we are talking about right now is the fact that DevOps is about culture and a set of practices. A culture of collaboration, a culture of quick feedback, a culture focusing on automation, and a set of practices including version control, continuous integration, continuous delivery and continuous deployment, infrastructure as code, standardization, and observability. The idea behind this step is to give you a 10,000 feet overview of what is DevOps and what are the important focus areas. As we go further in this specific section and in this specific course, we will dig deeper into a lot of these elements. I'm sure you're having a great time, and I'll see you in the next step. In this step, let's talk about our journey to DevOps. How did we evolve to DevOps? When we started building software, we started building it in the waterfall model. And slowly we evolved to Agile and then to DevOps. And now there are a few variations of DevOps as well. Let's now focus on the journey from waterfall to Agile to DevOps. Let's get started with waterfall. The first few decades of software development was centered around the waterfall model. Waterfall model approached software development the same way that you would approach building a real estate project. For example, you're building an amazing bridge. You do things in a number of long phases. You want the bridge to be built in a very, very safe way. And that's why you'd be building a number of long phases. And that's the same approach which software development teams took. They worked in long phases: requirements gathering, design, build, test, and deploy. Each of these phases could sometimes run from weeks to months. And taking software live, showing your working application to users, took sometimes a few months, and in few very, very bad situations, it also took a few years. So waterfall model had one big team working in a number of phases with long release cycles, and there was no feedback from the users until very, very late stages. The development and the operations teams worked separately with conflicting priorities. The goal of development team is to build as many features as possible and take them to production. However, the goal of operations team is to keep the production environment stable. And there is a conflict, because if you make too many changes, then the production environment will not be stable. So developers and operations team worked separately, and they had conflicting priorities. And this resulted in slow delivery and unhappy teams. I had the experience of working in several waterfall projects. Some of them had release cycles of 3 months. So if you want to take a new feature live, it typically used to take 3 months. It was slow and it was not fun at all. And slowly, Agile started becoming popular. We started building software in iterations. Agile brought the business and the development teams together, and they started to collaborate and bring customer feedback directly into the development phase. We started building software in iterations, and this enabled quick customer feedback. In Agile, there was also a lot of focus on code quality and also creating automation tests. I personally had a wonderful experience with some amazing teams in the Agile model. Software engineering, which for me represents all the efforts in building software from requirements to taking the applications live, for the first time was as enjoyable as programming. But does evolution stop? Nope. New challenges emerged. Development teams started moving fast. However, operation teams lagged behind. Operations teams are responsible for creating environments, for configuring environments, and deploying applications into the environments. And a lot of these things were done manually. Manual deployments and manual environment creation started causing bottlenecks. And that's where we started evolving to DevOps. The goal of DevOps is to bridge the gap between development and operations. And some of the key enablers, including automation, CI/CD, testing, infrastructure provisioning, focusing on collaboration, having shared responsibility between the dev and the operations teams, and focusing on monitoring, focusing on observability, trying to fix issues early and improving continuously. And this resulted in faster delivery with fewer errors, scalable, reliable systems, and happier teams and users. In this specific step, we focused on the evolution from waterfall to Agile to DevOps. As far as I'm concerned, the key thing about DevOps is the mindset shift from silos, from working individually to shared ownership, shared responsibility, from throwing the code over the wall to the operations team to building it and running it together, from manual work to automated continuous delivery. Are you excited to dig deeper into this wonderful world of DevOps? Let's continue this journey in the next step. In this step, let's dig deeper into continuous integration and continuous deployment, CI/CD. There is also another word, continuous delivery. We'll talk about that as well. So, what is continuous integration? Developers work on the same code base. If they don't have coordination, there can be compilation issues, there can be code quality issues, or unit testing issues. If I'm deploying the code into an environment, at that point in time, if I see that there is a compilation issue or there is a code quality issue, that's not great. Can we catch these issues early? That's where continuous integration comes into picture. As soon as code is merged into a shared repository, can we run automated builds and tests on every change? So as soon as something is committed into version control, can I compile code? Can I build the package? Can I do code quality checks? Can I run unit tests and any other tests? That's the goal of continuous integration, to catch bugs early and integrate code often. So you'll have fewer integration issues, fewer defects, and faster feedback. Now, where is the next step done? Deploying into environments. That's done during continuous deployment or continuous delivery. Now, what is the need for continuous deployment and continuous delivery? Let's say you have continuous integration in place. Your code is compiled, packaged, tested. However, deployment is still manual. This will delay feedback and this will delay delivery. Can we automate deployments too? That's where continuous delivery or continuous deployment comes into picture. Automatically deploy tested code to environments like dev, QA, and even production. There's a small difference between continuous delivery and continuous deployment. We will talk about that at the end of this specific step. For now, let's not worry about which environment. Let's only focus on the fact that you are automatically deploying to an environment. So if you are not only compiling code, building package, doing code quality checks, running tests automatically, but also automatically deploying to an environment, that's when you are doing either continuous deployment or continuous delivery. Now, where is CI/CD done? Where is continuous integration, continuous deployment, or continuous delivery implemented? It's implemented in CI/CD pipelines. So you'd create a pipeline involving different steps: build, test, and deploy. Code is built, tested, and deployed automatically. When does this process start? It's triggered on every code change. Some projects also trigger CI pipelines on pull requests. When there's a code review request, you want to make sure that the code is compiling and the unit tests are passing, and you'd want to make that detail available as part of the pull request to do the code review. Let's not really worry about it for now. For now, let's assume that it starts on every code commit. Whenever code is committed into version control, that's when the CI or CD pipelines are triggered. This would enable you to get quick feedback. Issues are found and fixed early. Now, there are a variety of tools that you can use to implement continuous integration and continuous deployment. You can use GitHub Actions, Jenkins. These are great tools to do continuous integration. Argo CD is a great tool to implement continuous deployment when you're using Kubernetes. You also have CI/CD tools in the cloud as well. In AWS, you can use AWS Code Pipeline to build pipelines. And as part of the pipeline, you can build software using code build, and you can deploy it using code deploy. You can deploy code to a variety of services in AWS. Similar features are provided in Azure by Azure DevOps. Azure DevOps also has the pipelines feature, and also you can deploy it to any of the Azure services. In Google Cloud, you can use Google Cloud Build to build your applications, and you can use Google Cloud Deploy to deploy the application to a variety of Google Cloud services. So we're talking about the fact that there are a variety of tools that you can use to implement CI/CD. The goal of CI/CD is to find issues early and fix them early. Now, there's one question still left off. What is the question? What is the difference between continuous deployment and continuous delivery? In continuous delivery, code is automatically tested and staged. So when you're doing continuous delivery, typically you would actually do deployment up to the staging stage automatically. So you'd run unit tests, you'd run automation tests, and you'd proceed with automatic deployments up to staging environments. However, you will not go live automatically. You will go live only after somebody like a release manager, a manual person, clicks deploy. So there is a manual gate. So when you're doing continuous delivery, there's a manual gate. Somebody has to manually approve before the code goes into production. However, in teams which are practicing continuous deployment, if developers commit code and all the tests pass, you would go live automatically. You would go to production automatically. So that's the key difference between continuous delivery and continuous deployment. In continuous delivery, there is a manual gate. However, continuous deployment does not have a manual gate. And therefore, continuous deployment needs higher confidence in automation testing, as well as monitoring, as well as in the release processes. So your automation tests when you're doing continuous deployment should be good enough to catch all bugs. And your release management processes should be really, really strong, and they should be enabling you to roll back quickly in case there is any problem with a specific deployment. In this specific step, we talked about continuous integration, continuous deployment, and continuous delivery as well. I'm sure you're having a great time, and I'll see you in the next step. Welcome back. In this step, let's focus on infrastructure as code. Whenever you'd want to create a cloud environment, you'd want to set up a VPC or a virtual private cloud, or you'd want to create a private network first. Inside that, you'd want to create multiple subnets. Inside that, you would create your servers, or you would create your virtual machines, and you would create your databases. Now, imagine setting up an environment like this. Manually, if it's a simple environment like this, you can do that. But now you would need to actually repeat it multiple times. I would want to create a dev environment, a QA environment, a stage environment, and a production environment. So there are 4 environments to create. And there might be hundreds of instances in each environment. So doing this manually, setting up VPCs, setting up subnets, setting up virtual machines, databases for thousands of instances across multiple environments is time consuming and error prone. That's where we go towards infrastructure as code. How about automating the provisioning of infrastructure and configuring the infrastructure using code? So, infrastructure as code is using code to define and manage cloud infrastructure. We are talking about automating the provisioning, creation of these servers, and configuration of these servers. For example, I would want to configure OS, or I would want to install a specific software on the server. So it's not just provisioning, but also configuration of the resources. The advantage is fewer manual errors and faster deployments. You'd also have consistent environments because we are automating everything. There is no chance that there will be differences between environments. And you can version control your changes. That's the advantage of using code. Just like your application code, you can also start having your infrastructure code under version control. So infrastructure as code is about using code to define and manage your cloud infrastructure. And there are 2 parts to infrastructure as code. So whenever you want to create hundreds of servers, it's not sufficient if you just create them, right? You want to configure them to have the right configuration. You want to set the operating system configuration. You'd want to install patches. You'd want to install software. Maybe you'd want to install Python or Node.js. You'd want to do that. So you would not only provision server, not only create server, but also you'd configure the server. You'd want to update the OS, install the software, and things like that. You'd want to automate both of them through code. So there are two parts to infrastructure as code. Infrastructure provisioning, which is creating resources, which is creating cloud resources like VMs, storage, databases, networks, and things like that. The other part is configuration management, installing software, packages, and doing runtime settings, maybe installing patches. All that need to be done on the provisioned resources. This is called configuration management. Infrastructure as code is a combination of both provisioning plus configuration. Automate everything from the creation of the server to the software which is installed on the server. And once you automate everything, it becomes repeatable and scalable. You can run it multiple times and you are sure that you will get the same server with the same configuration. Popular tools for infrastructure provisioning for creating resources in the cloud are Terraform, Pulumi, and others. In Terraform, we use a language called HashiCorp control language. However, when you're using Pulumi to create resources in the cloud, you're writing code in programming languages like Python. There are a lot of other programming languages which are supported by Pulumi as well. So you can use Terraform or Pulumi to create resources in the cloud to do infrastructure provisioning. And you can use tools like Ansible, Chef, Puppet to do configuration management. Once a server is created, you'd want to configure the software. You'd want to install packages. You'd want to install patches. You might want to configure an OS setting. All that can be done through software like Ansible, Chef, and Puppet. These are configuration management software. So we are now talking about the two parts of infrastructure as code, which is infrastructure provisioning and configuration management. And both of these have to be automated. The goal of infrastructure as code is to treat infrastructure just like code. Version control it, store it in Git, just like application code, and make sure that you test and review the code before it's used for deployment. Now, there are a number of cloud managed services as well for infrastructure as code. Earlier, we talked about software, Terraform, Pulumi, Ansible, Chef, Puppet. These are cloud neutral. You can use this across any cloud platform. However, there are also cloud specific services, cloud managed services. In AWS, you can write YAML scripts or JSON scripts using AWS CloudFormation and use them to provision infrastructure. You would see that typically AWS CloudFormation scripts are pretty complex. And that's why AWS also offers alternatives. For example, AWS CDK, AWS Cloud Development Kit. This can also be used to write programs and provision infrastructure in AWS. AWS also has a managed service called OpsWork. This is cloud-based Chef and Puppet. So if you want to run Chef or Puppet in AWS, you can make use of the OpsWorks AWS service. Azure also has ARM templates. This is very, very similar to AWS CloudFormation. You can write complex scripts to provision infrastructure. And just like AWS CDK, Bicep also allows you to write programs and provision infrastructure in Azure. Google Cloud has its own service called Deployment Manager, which you can make use of to provision services. And it also has first-class support for Terraform. If you're using Terraform to provision resources, Google Cloud makes it really, really easy. In this specific step, we talked about infrastructure as code. The goal of infrastructure as code is to use code to define and manage cloud infrastructure. You want to automate provisioning and configuration of resources. We talked about the two parts, provisioning and configuration management. We also talked about the software. Terraform and Pulumi are used typically for infrastructure provisioning, and Ansible, Chef, Puppet are typically used for configuration management. So the goal of infrastructure as code is to treat infrastructure just like code. And we also looked at the cloud managed services for infrastructure as code. I'm sure you're having a great time, and I'll see you in the next step. Hello, this is Ranga from In 28 Minutes. Do you know? We have almost 2 million learners learning from our courses on Udemy. And another thing you might not know, interview questions you have watched until now are from a course called Cloud and DevOps Interview Guide. With over 300 questions, it is the best cloud and interview guide in the world. Why am I so confident? First of all, we cover a wide range of topics. We cover 3 cloud platforms, AWS, Azure, and Google Cloud. And we also cover a wide range of DevOps tools, Git, GitHub, Docker, Kubernetes, Terraform, and beyond. Our goal is to continuously update the course as the DevOps space evolves. Check out the full course using the link below. We added in a special discount for our YouTube learners in the link. So do check the link out. And there's even more. We are giving away free access to the course every month to 100 lucky learners across YouTube. Here's how you can win. Just post a detailed review of the video on LinkedIn, sharing what you have learned in the video. And don't forget to tag in 28 minutes and also me, Ranga Karnam. Thanks for watching and happy learning. Until I see you again, here's bye from Ranga at in 28 minutes.